Okay, let's jump into our next. So there's our definition once again. And let's look at this problem. Let's just do a problem. Not too complicated, not too crazy. Let's just do a problem. So we're going to find the area of the region bounded by f of x, which is equal to x, and g of x is equal to x squared minus 2. And notice that there's no bounds here, because it's actually just asking for the area of the region bounded by it, which means they're going to intersect. Just doing one of these, like here's our g of x. It's just a parabola facing up. You do know your parent functions, don't you? I sure hope you know how to draw a frickin' parabola. I mean, that's kind of important, don't you think? And then f of x equals x. Well, that's just y equals x. So there's f. And there's g. So what we want to do is we got to figure out, well, what's the x values here where they intersect, so we can find this area between the two curves. Right, we want to find this area. So the game is, well, if we want to figure out where it is they intersect, we just set them equal to each other and solve. So we're going to take f, and we're going to set it equal to g. And we'll go solve for those values of x. So that can tell us our bounds, our a and our b. What are we integrating across? So this is going to be x is equal to x squared minus 2. Anytime we have an x squared in there, I mean, that means get everything over to one side, so we'll subtract over. Oh, convenient. Now we factor and solve. X minus 2, x plus 1. Therefore, x is equal to 2, or x is equal to negative 1. Hey, we just found our bounds. This is about as straightforward as these are going to get, okay, when solving for them. I got another one for you later that's going to be a lot more challenging. So that means our integration, our a is negative 1, our b is positive 2. So now we can set it up. Now, beyond just this, setting up our bounds, it's also about what's on top. F is on top, isn't it? G is below. So that means F must go first. So it's x minus, and tell me what I do wrong here. What do I do wrong? What did I do that's incorrect? When you subtract, you need a freaking parenthesis. The g of x, we're subtracting it out. So we need to make certain that we use a parenthesis. We're going to create sign error. So it very much matters what's on top and what's down below. And use some freaking parentheses. So we have negative 1 to 2 of x minus x squared plus 2 dx. Now, let's go through and handle it. So we'll take an antiderivative. So we're going to get 1/2 x squared minus 1/3 x cubed plus 2x, evaluated from negative 1 to 2. How's your fractions, y'all? Are you starting to notice? Fractions pop up quite a bit. So we have 1/2 something squared minus 1/3 something cubed plus 2 times something. There's our first one. And then we have the same thing again here. So you thought the problems were tough in Calc 1, huh? Well, let's put our upper bounds in. 2, 2, 2. Then we put our lower bounds in. Negative 1, negative 1, negative 1. And now we have to make certain that we can add and subtract fractions. So we have 4 divided by 2, that's 2. 2 to the third is 8, so we get minus 8/3 plus 4. Minus negative 1 all squared, that becomes positive 1, so we get a 1/2. Negative 1 all cubed is going to stay negative, so that'll create a positive. And then minus 2. Oh, geez. Oh, geez. We're going to have to clean that up. Now, this is where I'm going to cheat. Don't need the parentheses around that. I'm going to distribute my negative in. Change the sign. Change the sign. So now we can just start putting like things together. 2 plus 4 plus 2 is 8. Let's put these two together. Negative 8/3 minus 1/3. That's negative 9/3 minus a half. So this is 5 minus a half, which ends up becoming 9/2. There's our solution. So areas between curves. Oops, that's what we're going to mess around with later. You got to know which one's on top, which one's down below. Got to be able to find the points of intersection. You have to be able to find antiderivatives using the power rule, and then you have to be able to deal with fractions. So these are the things we need to get awesome with so we can be successful. Because trust me, you're going to get further into this class and you're going to think, man, I wish we could do areas between curves. You will. Wait till we start doing solids of revolution. All right, so we'll be on to the next. I'm going to give you a more challenging one. See you there.